Hello and welcome back. So now let's backtrack to limits, or let's go back to limits, because now that we know how to differentiate, there is actually an easier way to find those limits that you couldn't solve by simple substitution, the ones that ended up in those indeterminate forms. And the way to do that is something that we call L'Hopital's rule. Let me take it. L'Hopital's rule. And it was actually John Bernoulli who figured out this rule, but L'Hopital was the first guy who put this down in his textbook, so he ended up taking all the credit for it. So the way L'Hopital's rule works is that L'Hopital's rule says that if you have the limit as x approaches something, let's call it a, of one function, let's call that f of x, over another function, which let's call that g of x, this limit is exactly the same as the limit as x approaches a of f prime of x over g prime of x. And this, remember, this is only going to work on a limit that ends up in an indeterminate form. If you have a limit which you can substitute and solve it, and you take the derivative of that in the numerator and the denominator, it's going to give you a different answer from the original one. So keep in mind that this only works if your limit ends up in an indeterminate form, which is like 0 over 0, or infinity over infinity, or something like that. So let me do one of the problem, and you see what L'Hopital's rule is all about. So let's say we had the limit as x tends to 2 of x minus 2 over x squared minus 4. And you can see if I just went ahead and plugged in 2 into this, that would be 2 minus 2, which is 0, and 2 squared, which is 4, so 4 minus 4, which will be 0, so we end up with 0 over 0, which is one of those indeterminate forms. So simple substitution doesn't work on this. But what L'Hopital's rule says is that this limit right here is exactly the same as the limit as x tends to 2 of x minus 2 prime over x squared minus 4 prime. And the thing to remember is that we're looking at this as two different functions, so do not use the quotient rule here, and I'm going to write that in all caps. Do not use the quotient rule. We're looking at these as two separate functions, one function in the numerator and one function in the denominator. So let's differentiate this. So this equals the limit as x tends to 2. The derivative of x is 1. The derivative of 2 is just 0. So it's 1 minus 0 over the derivative of x squared is 2x. I'm using the power rule for this. If you don't remember the power rule, you should go back and watch the video on the power rule. And then we have minus 4, so minus 4 becomes 0 when you differentiate it. So this equals the limit as x tends to 2 of 1 over 2x. And now we can go back and substitute, so this ends up as 1 over 2. You substitute 2 in for x, so that's times 2. And that equals 1 over 4. And this makes it so much easier to find those limits that you couldn't solve by simple substitution. You just take the derivative, and then you try and substitute. And if it doesn't work, and even after taking the derivative once, you end up in a indeterminate form, you can do this again. You can use L'Hopital's rule again, and then try and substitute again. But keep in mind that if you have a limit that it does not end up in an indeterminate form, then you cannot use L'Hopital's rule. If I were to use L'Hopital's rule on this, you can see that I would end up with the derivative of 1 over the derivative of 2x, which would end up as 0. So, and that's different from 1/4. So you can only use L'Hopital's rule on limits that when you substitute, they end up as the indeterminate form. But you can use it over and over again. You can keep deriving the numerator and denominator and until you get a form in which you can substitute, and then you end up with your answer. So if you have any questions, as always, you can send me an email.